space station will have rotating 6-member crews to advance research and technology in low Earth orbit, roughly 220 miles above the Earth. To replace the Space Shuttle, which is no longer delivering cargo and crew to the space station, NASA is entering an extraordinary new era. NASA is investing financial and technical resources to stimulate efforts within the private sector to develop and demonstrate safe, reliable, and cost-effective cargo and crew space transportation capabilities. Innovative spacecrafts and launch vehicles are changing the way cargo, and will change the way crews, are transported to the International Space Station and to low Earth orbit. Further, this is creating a market environment in which space transportation services are also available to private sector companies. Having opened low Earth transportation to U.S. industry, NASA is focusing on developing 2 necessary elements for future human deep space exploration: a crew vehicle called Orion Multi-Purpose Crew Vehicle, and a heavy lift rocket known as the Space Launch System, or SLS. The programs for these vehicles are moving out, intensely focused on meeting the goal of flying the new rocket and Orion without crew by 2017, with the first crew flight to take place in 2021. Using the lessons learned from over 50 years of spaceflight, NASA is testing and building an advanced space exploration system that will take our astronauts to deep space destinations humans have never visited and return them safely to Earth. The Orion will be outfitted for long-duration missions that reach far beyond low Earth orbit. For this reason, the spacecraft will incorporate innovations and advancements in the crew escape system, electrical power system, rocket engines, navigation and flight control systems, and communications systems. Orion will also require radiation protection for the crew and safe, reliable life support systems. This new spacecraft will be launched on the SLS rocket, which will send astronaut explorers on more challenging and distant missions. The rocket will be the most capable U.S. launch vehicle built to date, and with the Orion, will enable human exploration into the solar system. To journey into deep space, NASA is pursuing an integrated space exploration strategy that supports both science and human spaceflight goals and advances space exploration technology. Mission analysis and international discussions supporting this strategy are ongoing. NASA will ramp up our capabilities to reach and operate at a series of increasingly demanding destinations, while advancing our technological capabilities with each step forward. This will include early test and demonstration flights between the Earth and Moon, with NASA planning to redirect a small asteroid to a distant retrograde lunar orbit and send humans to explore it. Then possibly visit one of Mars' moons, Phobos or Deimos, or the surface of the red planet itself. By visiting a captured asteroid in lunar orbit, astronauts will learn how to do long-term space operations in a deep space environment while maintaining close proximity to Earth, and gain vital information exploring territory untouched by humans since the formation of the solar system. An asteroid mission requires new space transportation vehicles and systems that are capable of operating in an environment with almost no gravitational field. NASA is conceptualizing habitat and spacewalking systems with new spacesuit designs and anchoring tools, and robots that can work side by side with the crew or be remotely controlled. Traveling to Mars is our ultimate goal. Why Mars? Like Earth, Mars has an atmosphere, water, ice, and evolving geology. Robotic rovers that NASA has sent to Mars are investigating whether the planet has ever been capable of supporting life. Because of its Earth-like attributes, Mars is seen as an excellent candidate for human exploration in an isolated environment for long periods of time, with prolonged interactions between humans and machines, and with maintenance of sufficient quantities of food with adequate nutrition. NASA is working to identify solutions for all of these challenges on future missions. Once on Mars, astronauts will find evidence of extensive water erosion, channels, and floodplains. Astronauts will extract subsurface water for their use. The crew will need surface systems to produce air to breathe, fuel for vehicles, and equipment to mine and process resources. But then, these astronauts will have the distinction of bringing Martian samples back to Earth, which will transform our understanding of Mars. As always, new technologies developed to overcome the challenges of interplanetary travel will also find applications that improve life on Earth. Thousands of technological spin-offs have benefited American industry and citizens in the decades since NASA's 1958 inception, while NASA's cost to the American taxpayer is currently less than 1/2 cent of each federal tax dollar. So today, NASA looks forward to writing the next chapter of human spaceflight with its commercial and international partners, advancing research and technology on the International Space Station, opening low Earth orbit to U.S. industry, and pushing the frontiers of deep space even farther. As NASA's next chapter in human spaceflight evolves, there are new and increasing opportunities for each citizen to experience low Earth orbit, to become involved in new facets of an expanding space economy, and to view new vistas in deep space virtually through NASA's exploration. As Space Shuttle Atlantis launched on the last mission of the shuttle program, astronaut Commander Chris Ferguson said, "We're not ending the journey today. We're completing a chapter of a journey that will never end." Please join us for the next exciting chapter of NASA's journey.